looks like we have a system of equations. We've got 3 variables and 3 equations. I'm going to use the substitution method to solve this because I see that x has no coefficient. So if I solve for it, I'm going to be able to plug whatever I get in there in for x into this equation, and then I'll have y by itself, and then I can back substitute. That's my plan. So here we go. So I'm going to take this one, and I'm going to solve it for x. So I'm going to add 2y to both sides. That's going to give me x equals, I'm going to reverse these, it's okay, 2y minus 3. There we go, that's what x is, okay? Now I'm going to take that, and I'm going to plug it into this equation. So instead of x now, I'm going to put 2y minus 3. And that's awesome because now I have an equation that just has y. Just has y. I'll distribute the 2. I get 4y minus 6 plus 3y equals 1. Now 4y plus 3y is 7y minus 6 equals 1. I'm going to add 6 to both sides, and I get 7y equals 7. So then y, if I divide both sides by 7, y is 1. There's one answer. Boom. Y is 1. All right. Now that I know that y is 1, I can go back into this one, substitute 1 in for y, and that gives me what x is. 2 times 1 is 2. 2 minus 3 is negative 1. So that means that x is negative 1. Now that I know what y and x are, I'm going to go ahead and take this equation, and I'm going to plug in negative 1 for x. For y, I'll plug in 1, and we're going to solve for z. All right, so that's negative 4 minus 2 plus 3z equals 9. So negative 6 plus 3z equals 9. So 3z is 15, right? Divide both sides by 3, and I get that z is 5. So we put 5. We did it. Moving along. This is a pretty nasty question. It tells you that this graph right here, that's f of x, right? You first kind of got to figure out what f of x is before you can even do this problem, right? It looks like a logarithm. Okay? It looks like it's been shifted horizontally negative 3, right? So I'm going to go to my calculator, and I'm going to see if I can figure out what that is. So I'm going to go, okay, what does log of x look like? I'm going to jog my memory here. All right? There it is. Okay. All right. So I'm thinking maybe this is log of x shifted 3 units in the negative direction. How do we do that? We go y equals log of, so we'll call that x. Remember, if we're going to go negative, we add to x, right? If we wanted to go in the positive direction, that would be x minus 3. So I hit graph, and hopefully it looks like the graph I have there. And it does. So yes. All right? So yay. So now I think that f of x is, well, that is something else. So it looks like f of x is equal to log base 10 of x plus 3. So f of x minus 1. We're going to use function composition. What this says, f of x minus 1, this says everywhere you see an x in f of x, so right there, put x minus 1 instead of x. Substitute x minus 1 in there, okay? So f of x minus 1 is equal to log of, right, and now substitute x minus 1 in brackets. So that means that f of x minus 1 is equal to log of x plus 2. I'm just going to add those together, right? The negative 1 and the 3. Well, it wants to know what that is, right? So all I have to do is add 2 to f of x. Sorry, f of x minus 1 in order to get that. So x plus 2. It's fairly logical, okay? It's just giving you directions. Okay, now we got to figure out which one of these graphs is that. So let's go through. This x plus 2, right? It means that it should have shifted left 2 units, right? Okay. And then I'm going to show you 2 ways to do this. So let's find all the ones. So this one's possible. This one's shifted 4 units. It's out, right? Let's look. This one's been shifted 4 units. This one's possible. But this one, right, we've got a plus 2 there, right? That plus 2 at the end should have moved it up, right? This one got moved down. We're going to cancel this one out here. Oh. And we'll choose A. All right, well, let's look at this from another perspective. If you weren't going to figure out what f of x was, right? Look at this. Let's look at this. Let's look at this line, right, that it can't touch. Right, this asymptote. If I'm going minus 1, that should move this asymptote 1 unit in that direction, right? And this 2 should move it up, right? So it should be, so this graph should be transformed, minus 1. Foolish fool. Oh, the eraser's not working. Sorry, the minus is right. I've said this before, and I should have moved it that way, right? So we're looking for a graph that this line has been shifted here, and this has gone up too. So you could look at it, you could do it that way too, without doing that. You kind of try to think it out. All right, so there's a simple approach and a less simple approach. If this is f of x, right, this graph is f of x, it wants to know which one is this transformation, g of x. It's essentially saying, what is the graph transformed, this graph, but you transformed it by shifting to the right 1 unit and up 2 units. Okay?
Why did you go the extra math?
I wanted to show you function composition. I'm going to give you a couple ways to solve these sometimes, when I can. Okay, here we go. Let's get our properties of exponents going. We want to write this in this form. Okay, we're going to write that in that form. So let's go for it. First thing I'm going to do is I'm going to take this 2 out. And let's look at, and the second thing I'm going to do, it's cubed. Alright, so we're going to write this like this. I'm going to take the 2 out. That is a 3 on the top there. Guess I could zoom in a little more. Is that better? So, I can write the square root of m as m to the 1/2 power, right? And the fourth root of m is going to be m to the 1/4 power. So now I'm going to, the 2 I'm not doing anything with. This 3 though is going to multiply m, and I'll wind up with m to the 3/2 over m to the 1/4. So isn't that 2 times m to the 3/2 minus 1/4, right? I'm going to use that property. It tells me that I subtract those exponents. And 3/2 minus 1/4 is the same thing as 6/4 minus 1/4. We'll subtract those numerators and get 5/4. So hey, what's our answer? 5/4. If it wants the value of a, it's asking for that. Which matches that? Okay.
What happened to the m?
Oh, I got these things. Just fixed it. There's an M here.
What did the division of?
What? All right. In your solutions guide, I took a really long roundabout approach to this one. And I'm probably going to have to change it in the future. It's not an efficient way to do this problem. So we're going to do it in an efficient way. So maybe ignore that solutions guide and look at this solution instead. So my problem with this is that this 3/2 has got this 3x locked in. I would love to take these things and break them apart, right? And then put it back together. But I can't break it apart until I raise everything to the 3/2 power. So let's do that real quick. So this is going to be 3x over 3 to the 3/2 power times x to the 3/2 power. Now that I've got it like that, I can break it up. This is going to be 3 over 3 to the 3/2 times, right? Because there's multiplication in there. X, and there's multiplication here. And if I have the multiplication, I can split it out. So that's x over 3/2, x to the 3/2. All right. Properties of exponents says I can subtract, right? That's a 3 to the 1st power. So this is going to be 3 to the 1 minus 3/2 power times, and this is x to the 1st power. So I'll have x to the 1 minus 3/2 power. One minus 3/2. That's like 1 minus 1.5, right? Which is going to leave me with negative 1/2. And the same thing's going to be true for this one as well. Okay, let's go ahead and put these as fractions, right? We can do that, right? A negative exponent. We'll express that as a positive exponent, but it becomes a fraction. And now let's express these as radicals. So 3 to the 1/2 power is the same thing as square root of 3. And x to the 1/2 power is the same thing as square root of x. And I'm doing a lot of little steps, okay? So this is 1 over root 3 times root x, which is 1 over the square root of 3x. Hey! Looks like that's most simplified, and it looks like that matches B. But remember, guys, what I told you about squares, it means that there is more than one answer. There are at least 2 answers on this, right? So I've got to figure out which one of these is the same as 1 over the square root of 3x. Okay? Well, can I write this as 1 over 3x to the 1/2 power? Which is the same thing as 3x to the negative 1/2 power. Which means that E is our next answer. Okay, here's another approach. You look at this thing and you're like, yeah, I don't know. And that might happen, you never know. Let me give you plan B, right? Plan B, you see squares. You know that there has to be 2 correct answers, right? It wants you to say which of the following is equivalent to this, right? Which means that there are 2 answers that are equivalent to this. Which means that there are 2 answers here that are the same. So that means that as an alternative approach, you could try to figure out which 2 are the same, or which 3 are the same. Another way to say that is you could eliminate the ones that don't have anything that are the same. 1 over 3x, are any of these the same as 1 over 3x? Really, no, that's pretty easy to see right away. Right? All of these have roots, there's all these square roots and stuff going on, and all these exponent powers, there's no way any of those are equal to 1 over 3x. Alright? 1 over square root 3x, that's possible, maybe. Right? So if I hadn't done any of this work, I would list that as a possibility. All right. 1 over 3 times root x is the same thing as 1/3 times root x. Well, it can't be the same as this one, right? That's not the same as this one, and it's definitely not the same as this one. So I would cancel this one out. And then these 2 definitely aren't the same, right? D and E are absolutely not the same. And I would say, hey, this is the square root of 3x. Are any of these equal to the square root of 3x? No. So then I would check and see if these 2 are the same. If B and E are the same, then choose them. So it's multiple choice, okay? Cool thing about multiple choice question is there's always another way to do it. Multiple choice usually leaves you with an alternative way to find the answer. If you don't know how to get the answer the way that they're thinking you should get it, you can usually use a process of deduction. So look out for that. 13. These 2 functions are shown, and this is another reason why I was showing you the function composition, because it has come up again. So, we're trying to find what this is. We're going to go piece by piece. What's 2 times f of 1 minus x? First of all, f of 1 minus x is telling me that instead of x, put 1 minus x, okay? So you're going to put 1 minus x here. So instead of x, I put 1 minus x right there, okay? 2 times f of 1 minus x is just saying whatever you got for f of 1 minus x, multiply it times 2. So 2 times f of 1 minus x is just going to be, really simply, 2 times that. Right? It's fairly logical. Okay. We know what, now we know this piece, what's this? If g of x is 3 times, g of x is 3 minus x, then 3 times g of x is just 3 times 3 minus x. Again, it's pretty logical. It's just telling me, hey, if g of x is 3 minus x, 3 times g of x is 3 minus x. Super logical. Now we can put it all together. We said that 2 times f of 1 minus x is 2 times 1 minus x quantity squared. And that's going to be minus 3g of x. We said 3g of x was 3 times 3 minus x. And now the question is asking us, multiply this thing out and figure out what the coefficients are. So let's simplify this thing. So this is 2 times 1 minus x times 1 minus x minus, I'm going to distribute my 3, 9 plus 3x. Let's go ahead and multiply 1 minus x times 1 minus x. 1 times 1 is 1. 1 times negative x is negative x. Negative x times 1 is negative x. So we've got 2 negative x's, right? Oh well. Negative x times negative x is positive x squared. I'm going to go ahead and combine these like terms inside of these parentheses. And now, distribute the 2. 2 times 1 is 2. 2 times negative 2 is negative 4x. Sorry, 2 times negative 2x. 2 times x squared is 2x squared minus 9 plus 3x. Let's combine like terms. So, and let's go ahead and put the 2x squared in the front because that's where it wants it. And then 4x minus 3x is negative x. And 2 minus 9 is 7. So then we can fill in the blanks. It was a 2x squared, a negative 1x, and a negative 7. Yes?
So if you have a number and it's x squared, that translates to 1 minus x the whole thing squared? No? You said something about the numbers, about x's, how they translate.
Yeah, that's what it says, f of 1 minus x. Is saying that in f of x, instead of x, put 1 minus x.
Oh, I see.
It's asking you to substitute. All right. Joanna, she's using a function to calculate profit. She sells N cakes in her store. So P is profit, N is cakes. Joanna apparently has cake.
No.
Huh? Yeah. There is something very weird about this problem. I don't know why they have this N inverse of P. This F inverse of P there. What they're asking for is not the inverse. I'm not sure why they've used that notation. The correct way to solve this problem is to not do this. Something's really weird about that, and I really haven't had the chance to get to the bottom of it. What you want to do is, if it's saying a formula for the number of cakes she needs to sell for a given profit, right? This has profit for cakes, right? and you want cakes for profit. So if we have a formula that says P equals 30n minus 450, and we're not calculating the inverse, we're just going to solve for n, right? And that's what's messed this thing up. So if I need to solve for n, I'm going to add 450 to both sides. So P plus 450 equals 30n. And then I'll divide both sides by 30. So that would give me P plus 450 over 30 equals n. And there we go. So we wrote an equation that if you plug in P profit, it'll tell you and how many cakes n we need to make. Okay? So that's what goes in right here. And it is not the inverse. So that's misleading. Now, what number of cakes do we need? So essentially what we are doing is we're saying n equals, well, okay, our profit is 500. That's what that is, right? P stands for profit. So if we plug 500 in for profit, that tells us how many cakes we need to make. Wow, I'm not sure how I wrote 33. What I need to write 30. So 500 plus 450 divided by 30. That's approximately 31.667 cakes. We're not going to make 0.667 of a cake, right? So the answer would be 32. We want to put a whole number of cakes, right?
So wouldn't you round down?
No, you got to go up because you would have less profit, right? You would wind up with a number less than 500 if you did 31, and going over is better. All right, that is a lot of cake. Gotta find Joanna's ground. Just kidding, sorry. My God. Or Joanna puts pictures of her cake on the ground. To promote her business. No, that's okay. Okay, here we go. Number 15. The weirdest thing about this is trying to figure out what this is telling you. What in the world does that mean? So remember, we would draw a table that had x and f of x in here, right? So f of negative 2 is telling me, okay, so look, if I say f of negative 2 equals 0, which is one of the things there, right? This tells me x equals negative 2, and this tells me f of x equals 0. You know what I'm saying? It's saying you input negative 2, it outputs 0. So that means I could say that that's true, and then it's also true that that's going to happen. That's what that says. That points to a table like that. It also tells me that I have a maximum of 8. So if I was told to graph this, I very well could. Oops. Because I've been told that it has the point negative 2, 0, and there's also a point 2, 0, and then the maximum is 8. Yeah? Well, cool. I mean, draw a parabola. It says it's a parabola, doesn't it? Or does it say it's just a function? A quadratic. Which is a parabola, right? So if you select the quadratic function button, it's only going to let you draw parabolas.
So like, don't you like press it and then it draws the lines for you?
Yeah, and then you move them.
Yeah.
You're able to move them around. So
like, you just have to enter in the points and then it draws for you.
that's it. This is a really easy question.
Uh,
This one's not super bad. The numbers are all there for you. You just have to interpret. You don't have to do any algebra for this. All right. Oh, I missed the bottom. Hey, the function f is symmetric about the y-axis, right? Because for all values of x, f of negative x is equal to f of x, right? If you plug in a negative number, it's going to output a positive number.
Because it's just according to the function, f of negative 2 equals 2.
Yes, exactly.
Oh,
Yep, perfect. F of negative 2 is equal to f of positive 2. Perfect. That's a great way to say that. All right. The scientist. All right, guys, remember, these exponential growth problems are always of the form. Some p of x is equal to a, which are our initial value, right? Times our rate times t over we'll just say t for now, okay? Oh, okay, I don't have my rates. This is t over half-life, right? If it's half-life, or t over how long it takes to double, right? So there could be a number of different things. I'm going to call it m, just for now. It's going to be either your half-life, it could be how long it takes to double, it could be how long it takes to triple. It's however long it takes for you to achieve this rate. So this information has been given to us. The initial is 10 million micros, so that's A. Our rate is 2 because that's doubling, right? T we don't know, and M is how often it takes to double, or how long it takes to double. It takes 20 minutes to double, and I have answered the first one. So, and it's M of T, sorry. So this should be, my bad, M of T instead. All right, so it wants to know how many minutes it's going to take to double, which means that I need to solve for T. When M of T, or P of X, as I said, is 67. So it's asking me to solve this. Okay, let's go for it. 67 divided by 10 is 6.7. So that's how I got that. I divided both sides by 10. Now I'm going to take log base 2 of both sides to get rid of that exponent. I'm using log base 2 because I have a 2 in my base of my exponent.
But it's something good for you.
Okay.
You always think that I think you so.
Remember, we can pull this exponent out to the front because of properties of logarithms. That's going to be log base 2 of 2. Log base 2 of 2 is 1, right? Yeah? So that log base 2 of 2 is going to go away. And I'll multiply both sides by 20, and I get 20. Log base 2 of 6.7 is equal to t. let's go ahead and calculate that. So t is going to be approximately, and let's see, before I put that in my calculator, they want me to round how much times to the nearest minute. So we're going to round to the ones place. Let's go to our handy dandy calculator. 21. All right, so I'm going to hit 20. I'll go to math, and guys, this is the exact calculator that you're given on the test. So if you don't have the log base function on your calculator, it's going to be there on the calculator that's available on your test. Just click the little calculator button. And it's log base 2 of 6.7. Hit enter. And we're going to round to the nearest minute, right? So it's approximately 54.883. But we're going to round. So 54.883. But for the purpose of this answer, it wants the nearest minute. So we're going to say 55 minutes. So fair warning.
Why? Oh wait.
This next problem is okay. Guys. Okay, this is the deal, okay? If I want to know what cosine theta equals, so if I have this, there's a way for me to figure out what theta is. So, if cosine theta is some number, the way to solve that is that theta is going to be equal to cosine inverse of -4/5, okay? I can just put that in my calculator, right? It's a simple calculator problem. So we'll go to my calculator, and where cosine inverse is you're going to hit, see your cosine button, hit second, hit the cosine button, put -4/5. And my bad, my calculator is not in the right mode, okay? So that doesn't look like an angle, right? An angle of 2.49 degrees, that's weird. If you get something weird, what you need to do is check. Mode. That we're in degree mode, okay? Because it's giving me that in radians. That's in terms of pi. I would like degrees, like 60 degree, 90 degree, and so on, right? So if I hit enter, and then I go back to my calculator, and I calculate this, it's going to give me my answer in degrees. Right? This answer is in terms of pi, which is weird. I need degrees. That makes way more sense. So 143 degrees, around 143 degrees.
What was the conversion? Was it like theta cosine equals, when you're trying to convert? Like
That conversion is on your formula sheet. So you always have it, yes.
Okay.
Yeah. What did I just say? Approximately, huh? 43? Sorry, my eraser doesn't work. Point what to the 10th? Point 1. I don't know why. Oh, it's working now. Okay. Sweet. Cool. Okay. We did it. All right. I would love to squeeze in another one. The Ferris wheel. So a little more trade. Yeah.
So that's just that theta and y thing, like those charts we made in that practice sheet?
Yes. Yes, exactly. Yep, you can do that. It has charts. So check it out. It's a repeating pattern. You see that? 1, 7, 13, 7, 1. All right. What's going on is, and are we looking at sine? So it's going like this, right? You could draw a picture of it. Up here, this is, it goes up to Why do you erase sometimes when you don't? So this is going up to 13, right? And then the low point is 7. Yeah.
7. That's what went to 0.
Yep, and 7 is going to be your middle. From that, you can figure out the amplitude, right? This distance is 13 minus 7. That's what A is, right? So that's going to be 6. So that means that A is 6. So I can choose this one.
It's so good.
And that's it. Not it. I don't want you to look at that.
I finished it.
Okay. That is awesome. When we come back, we will look at part B, which is much more complicated than what we just had to figure out now. Yeah.